Good morning. Some music. I forgot a couple things. Dashboard. Phone. Plug in the phone. It is rather helpful. All right. And today we're going to try to get this computation a little bit more multi-threaded, multi-core friendly. And thank you for the follow. Anolas, 1972 from yesterday. I don't remember if I got you yesterday. Morning, Carter. Oh my goodness, it's early. Okay. Now, I've been toying around with a couple different ideas in here. Everything's. What am I missing? I feel like I'm missing something. I don't know. I did rename a couple of things. Ship is now ship config because this comes out of the configuration files. We have the ship broken up into a number of pieces, and this is so that we have smaller pieces to lock on. Kind of like a little bit of a entity component system, but not so much. Here's the Armada. We have hash maps of vectors to ship offense and defense. What am I doing down here? What is this? Oh, right. Okay, get to that. What I would like to do is have the Armada made up of smaller vectors. Basically chunks of things. So this might end up being a vector of vectors. And then have it so that the inner vector is actually protected with sin or commutex. So we kind of chunk it up so that the cores that are attacking or defending, they're going to be blocked on each other a bit less than they would otherwise. I think it makes more sense for the defense. We'll have to see. So in order to split this up, some really kind of interesting setups. Right now we only have offense and defense, but what if you had a three-way attack or a four-way attack? Who do you actually attack? The defense is going to be like an array of armadas, or we'll just have to have like multiple armadas being passed in, or maybe the offense and defense because maybe they're teamed up. And right now, the most time is actually spent in here. we do run this, oh, it's going to compile first. Cancel that. It did toss time at the beginning of that command. Get some water. Oh, something blew up. That's right. I already took a stab at this. Yeah, I was trying to use Rayon here, our intermutable. The problem I'm having is with, actually not the defenders, but the not the offense, but with the defense. Hey, give me a moment. I'll be right back. All right, to get the dog. Dog was annoying my wife. And let me see if I can fix that network blip. We lost some packets. We're losing packets. It looks like it's my devices. Who knows? All right. So one way to actually do this is to chunk up these pieces. Have different threads work through each chunk. The problem is that, well, there we go. The offense ship will be attacking some other armada, and when offense fires, his energy goes down. What's in here is the energy. And when he attacks, the shields and the defense go, or the shields and the hull go down. So you basically, right now you have one core blocking on all of the offense. And then it would be occasionally blocking the hash map for the defense. If I wrap the whole of the hash map into in a lock, we could, yeah, we couldn't do that very well. I think we get a decent speed up, but it's not enough. I want to try to make these smaller. I guess we could try to make each element in the vector locked on. We did that. Wait, when do we run out of resources for that? Like, how many arcs can we have? Good safety, breaking, running references. Is there a limit? was a mutex. Hmm. I'm not finding limit or system on there anywhere. I didn't think that you could just have an infinite number of these. Well, let's try to just lock on each element. It's going to be an vector of atomic rough counted mutexes. We need mutex. We're going to use parking lot for mutex. Oh, it's up here with a read-write lock. I don't think read-write lock is the right thing here because it's going to be rather write heavy. So we'll just use mutex. All right, let's work through these. We're going to go to create spawn. We call it spawn ships. Okay. Oh, I put that on the wrong level. Needed that on the push, didn't I? A new arc, followed by a mutex. Okay, so now we have spawn. We're going to go back to the run battle. First thing we do is we spawn the ships. That's good. Next, we attack. Now these I don't have to have. These aren't mutable armadas anymore, are they? They might just be references to armadas. Going back up to the this set of so marker A is there. I don't think we need mutable here. Because now that those are in mutexes, we should be able to control it on a per field basis. So we want to choose a ship in target fleet as a defender. It'll be one of the targets. So if we get one of these that's mutable entry in there, I don't think that we need that, do we? We don't mutate it. This target here, this is going to be a dot lock on the target. No field energy on type, arc, mutex, parking lot, yada yada. Okay. Oh shoot, you're in the browser. Nobody said anything. Not your fault. I should have had that. So here, the target fleet has each one of these elements here wrapped in a atomic rough counted mutex. It's standard arc and parking lot mutex. So I need to look at parking lot in the I'll have to dereference it. Got it. I say minus equals here, or do I have to? Yes, the ship offense should have energy. Oh, don't, no worries, Carter. We'll just cut that from the, when we push it live, we'll cut that segment. Okay, what do we have here? There's a couple things that are right. It's atomic, rough counted, yes, check. Got a mutex, check. And it's the offense ship, great. Those are good. That needs to be mutable because we're actually going to mutate it. Why doesn't it think it has energy? Set a B marker there. This should be ship offense. Ship offense has energy, yes. Good. Field energy on type. I would expect that this can deref through there. should read the docs. No poisoning. 1 byte of space. Standard library boxes and mute text due to platform limitations. Yes, that's what I was remembering. Does not require drop glue. Okay, it's good. Mute text new on our tape. Type. Probably should have. So that's okay. What if we look at the example? Calling lock on the data, mutable data. They dereference it here. And increment. This is like exactly what we're trying to do. Except we have ours in a giant vector of 100 million spaceships. Do I need to wrap that? Oh, that's shooter. I'm looking at the wrong one. Here's target. Ah. Oh, where's shooter? My goodness, I'm looking at the wrong thing. Or shooter in fleet. Okay. What do we need out of shooter? We need to lower its power for the attack. I think that's all we need to do for it. We'd probably get that information out of shooter and have a very small lock time on it. Let's do that. Where does attack come? Oh, attack is shooter ship. So yeah, it's already able to dereference stuff here. So we have shooter ship. Should be shooter.energy. Oops, wrong place. Shooter energy and what was it? Attack? We wanted. I think it was attack. Oh, I see, but attack's kind of a function of that. We're going to create a little block here. A lock on shooter. Gonna move this in there as well. Actually, we don't use energy down here, do we? Consume energy for the attack. Is what I wanted to move up here. Wow, this block is getting way out of hand. Let's undo a little bit of this. So really, I just want to lock probably long enough to be able to do that, and then this here. But it looks like okay, this might be reasonable because I don't want to hold the lock on the shooter very long. It's kind of silly because I don't think there's going to be any thread contention on that. Okay, let's undo that. I think that Rayon is going to take care of that part for me. Go back a little bit. Oh, but that there is wrong. Lock on the shooter. Now this spot here, this is what I changed earlier, and I don't think we want that. We wanted to decrement the amount of energy that the shooter had by the amount of the attack. That's supposed to be a minus equals. Let's just do a double check on this. So we get the shooting spaceship. Figure out what its max attack can be out of its kind of ship design spec, the attack amount, and the amount of energy it has on hand. It's going to skip attacking if it has no attack power, pretty much meaning its energy is 0. So let's just change that. Bump that up. Attack is limited to how much energy you have. Good. Choose a target and another fleet. So we choose a different fleet. Weighted distribution for the fleet that we choose. It's distributed by size. So we choose evenly between the fleets based on how many ships are there. So every ship has an equal chance to be attacked here. And then once we have a fleet, we will sampling of which ship in the fleet to choose. Using this actually sped it up by like, I don't know, cut the runtime in half. Instead of choosing, instead of calling a choose mutable on it, much faster. As we set up the weighting beforehand. So the expensive part, well, one of the expensive parts is already done. Then choose a ship, fleet in the ship. All right, so here we're using the fleet ID and the fleet index. Which fleet and which fighter, which ship. Consume the energy for the attack. Good. Hack the shields. Shield damage is the minimum amount of the attack versus the shield. So if you're just about out of shields and it's a huge attack, you're gonna go right through those shields, take them down, and remainder of the attack is gonna go onto the hull. Okay. That looks good. So after the attack, we're gonna go to destroy. Okay, our losses, where do we use losses? There. But it looks like we have a lot going on otherwise. I don't know if it makes sense to actually multi-thread this, but we can. Might as well. The big sink is kind of the attack though. Let's keep this light to incremental changes. So if the hull is 0, meaning that the locked element's hull is 0, then we remove it from everything basically. Okay. Let's destroy and then refuel. Oh goodness, this is going to be a lot of stuff. A lot of locking actually. So we can do that across threads very easily there. Same here, parallel iterator from Rayon. Even with the locking, this is probably going to be faster. I turn my poor little computer into a skillet though. All right. Our iter there. Another lock. What's next? Refueling. Nomad, morning. All of these intermutes. I don't think we need all of these intermutes anymore. So here we're getting the fleet. 2 different fleets. So Nomad, today we are working on using Rayon to get some, to be able to easily multi-thread this. Want to just spread the computations across the cores and have it run more quickly, spend less time. Yes, thank you. Parallel processing. It's early. I'm not doing all of them right off. The one that I had, you're still, it's still tired after 9 hours of sleep. I think I'm fighting something off too. It's not the pandemic. I'm just stressed. And this is nice. This is kind of a nice kind of escape from the grind for me. It's just going to be an iter now. The ship, that fleet. We're going to rebind that ship is equal to ship.lock. Looks like we're going to be doing the same thing a little bit. It's not declared as mutable. It's actually exhausting. Yes. Yes, I can imagine. That is the amount of people don't get how much stress has an effect on the body. You get any coding in just for fun? To keep the practice up. So I needed that iter mutable on that one. That's cool. See, I don't think I actually need to borrow it as mutable. Okay, well, it's more happy. Oh, this isn't even used. Why? I think it's because I now use the RNG in attack. Basically spawn it per thread. Okay. So do I do that per thread? Actually, that's probably not a good place to have it, right here. It's for each iteration. No, that's going to be slow. Yeah. And now let's deal with these. Interesting. I wonder if there's a way to provide something on each iteration. So par iter is going to run this closure on each of the cores, splitting up the work. I'm going to need each one of those to have its own thread local random number generator. Let's look at the docs for small 5 rand. Here it is. Oh, I was looking at performance stuff in random. Maybe it's more of a rayon concern, being able to provide something to each one of these. Want it to have like context or something. Button, fold. Oh, fold maybe. That applies a function. I just want context. Filter, enumerate, empty, clone. Chunks. Cloned, copied, emptied. And fold with. It's kind of, this will map with. And I kind of want something like that. All right, back to the code. We're doing 4 each on that. I wonder how it does fold, actually, because fold executes OP on the given init, operation on the initial value. Each item produced by the iterator in parallel. Init value will be cloned only as needed. Does not require the type to be sync. Okay, well, is not weighted index, but is small vec small RNG. There we go, small RNG clonable. I don't think it is. Oh, it is right there. Okay, so we could do that for each width. All right, and what are the arguments? How does that come? Double T. Yeah, this is going to be 2 arguments. This no longer needs to be mutable. Pass it in there, it gets cloned when it needs to be there. And it goes in. Wow, okay. That's really handy. Check it. Looks good. Okay. See, how do you set the update speed? F2? There's too much stuff in there. All right, we're gonna just run it. For the memory, I've got 8 gigs of 16. And we've got all the OBS stuff, so who knows? We might actually drop some packets here to the computation stuff. It's taking a lot longer to spawn the offense. Normally this is just real quick. We're just shifting time. Spawning up all those arc mutexes. Yeah, the other one was faster. The single-threaded one was faster. Would have been done already. 25 seconds. My locks are too granular. Yeah, 100 million each side. Yeah, before this change, this only took 20, 30, no, 25 to 30 seconds. So if we stash that, build it again. Not 27 gigs of RAM, no. No, I only have 16 on the box. I need the locks because I need to be able to have multiple threads operate on elements inside the same vector. So yeah, here it's using one full core, but it only takes 28 seconds. Yeah, so Nomad, basically the idea is that you have these opposing space fleets of ships, and one side attacks the other side. In order to, I guess, make this simple, my fleets are described by their properties. I could attempt to, where are they? Hold on, the Armada. So I could attempt to split this up more easily. I think that what I tried was actually putting an Archimedex around every ship property in the list. Probably silly to do it like this. Just wanted to try it and see what that performance was like. No, that was educational. It's neat. Took a lot longer to spawn. You put the Archimedex on the outside of the vectors. We're gonna have to make sure that the locking inside of the loops is pretty granular then. So let's try that. Oh, go ahead and write it. That's right, we stashed that. Okay, stash. Okay, good. Let's just drop that stash. Gonna be moving some locks around. here. Wait, why is this for index in, oh, the length? Hmm. Yeah, that's a little wonky there on the range. Actually, let's go back up one. No longer have to rebind ship there. Oh, I see. We have to lock there. Wait, did I get that backwards? Don't lock. Oh, it's lock on that side. Goody. Okay, so here. Four of those. There we go. Looks like there's going to be a bit of that. All right, let's see. We've only got a couple hundred lines. Let's look at these real quick. No, don't have to look at those. Armada though, hash map of arcmutex protected vectors. Okay. Let's see. Do these have to be? I don't think those have to be mutable anymore. Why is attack okay with that, but not destroy? So I'm calling par iter. So spawning was faster. I'm guessing there's a lot of contention on the attacking stuff. Actually, if we do a tree F5, refueling doesn't usually have that sort of hiccup there. Oh, and obviously something's wrong. Chips that need fuel and shield fuel, not actually mutating one of the values. Probably getting a copy. Hey, Togglebit. Sorry, I missed your message. Is it because Armada is a reference and intermute requires immutable reference? I think so. I think that's exactly right. Wow, that's taking a long time to refuel. Let's set some timers around these things. The spawning seemed reasonable. It currently doesn't take long to spawn. It's done spawning. It takes, I don't know, a second to spawn. I think the refuel is taking a long time at the moment. I probably have some sort of contention issue over there. Or deadlock. Ooh, I wonder if it's a deadlock. See right there after refuel percent. There we go. Last message received, refuel percent. Yeah, it's probably in here somewhere. This one looked pretty sketchy to me, this defense lock happening twice for the length. Let's get that out to a local variable. Oops, didn't mean to search and to rename. Say this will be ship mount. Oh, but it has to do this on every iteration. That's right. No, we're refueling. It doesn't. It should be okay. So we're not removing in this iteration. I think that during the attack and the defense, the locking on the target system has to be reduced because right now it's holding the lock for way too long, which is why it's not going faster. There we go. Took it a little bit longer to do the refueling, but only added 20 seconds to it. Toggle bit. I don't know yet. I don't know if there will be a Godot interface on this one. Probably some sort of web interface, definitely. Not sure. All right, let's add some timings. On battle. But now equals instance dot. Is it now? Let's see. Use standard time instant. Let's see. Spawn duration. Actually, I don't know if that'll have a pretty print on it. Start to elapse there. Thank you. We'll just wrap a couple of these. Destroying the ships. This is marking them as destroyed and removing them from the arrays. And the refuel step. I think we've made progress on one, but lost some on the other. So yeah, 1.8 seconds on the spawn's not bad at all. I want to see this one. How long the attack takes. 27. Let's reduce the contention time in here. Overall 43 seconds. So what's under contention? We have this fleet here. Whole thing. Okay, but which fleet is that? Or ITER. We receive the fleet, we lock on this. What is shooters? Shooters is an armada, so in oh, I see. We didn't actually do much for like a speed up here. I was just notified that the car won't start. Guess that's what happens when you don't run it, battery slowly dies. But you can guess what I'm going to do today. Recharge your battery. All right, what are we doing here? For each width, receive the random number generator and the fleet kind and whatnot. Okay. Cars are bad. I don't see that this is terrible. That seems okay. Oh, no, 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 it is. Oh, wow. Yeah, we can't do that. Can't do that. What does offense consist of? Why am I doing a double iteration on this fleet? Offense should be... Oh, it's a hash map. Oh, oh, I see. Okay, so we'll put that lock back. And this one here, this one needs a parameter. Is not an iterator. Strange, why? And why is fleet mutable? The shooter needs to be mutable? Need to operate within a closure? Oh, oh. Oh, yes. Yes, you are right. Okay. So we're going to be doing this. Shooter is going to be a part unit for each. For each width. Because we have to pass the RNG through again. And then we'll toss that on there. I'm missing a semicolon there? Clone is not satisfied. Yeah, that was it. Strange. Is it because this was a clone? This is an actual instance, and before, excuse me, before what we're passing in is a reference. So here, the reference. Here, it's not a reference. So we were passing in a different type here. Or it was a reference? I don't know what the type of that is. Hmm. Oh yes, and continue within a closure. Doesn't really work. Guess I could just return. actually want the reference. I am kind of curious, what is this actually? Can we be more explicit? Or let's see, and mutable. Trait bound, double borrowed, small energy. Jeremy, morning. How's it going? Which means you end up with a reference to a reference. Oh, I see. Expected, let's see, founder expected dual reference. Yeah, we've got, oh, interesting. Okay, so here, pass it in. Shouldn't be like that. No. Actually, I like the comments and the they're insightful, especially when you use line numbers. That makes it very explicit as to what you're referring to. Sometimes I just don't see this. So now at this point, oh, that's fun. So if we add this here, well, we can put what we expect to have here. So this is going to be a small RNG with whatever on the inside. I want to provide that. I don't know what that is actually. Can it tell me? Type argument, sure. So it wants the reference. That seems weird. Or, whoa, hold on. Far into this. Let's comment that out for a moment. This one here. Without RNG, it's content with that. Why? Look at that signature. Oh, Rayon, where art thou? Oh, here it is. Or init t. T is send and clone. OP. It's immutable, an exclusive bar to T. Okay. So that's send and clone there on 336. Then on 337, it's technically RNG. It should be. So what does it say we're actually passing here? Clone is implemented for shared borrow, but not for exclusive borrow. 2 errors. How to fix them? Now it shows you the other 200 you couldn't show you before. Yes. I think you're right in that there has to be dereferenced, but I think also the mute over here was confusing it because clone isn't, for whatever reason, clone isn't on the exclusive borrow for small RNG. Okay, found struct small RNG. There we go. No, that's not right. Cannot move out of dereference of RNG because it's behind immutable reference. So if we rebind that, should be okay. Oh, probably. Yeah. Let's try that. So for here, right, that's a great idea, actually. That's a really good idea. Thank you. All right, where were we before? So we just adjusted battle. Battle was previously 27 seconds. Give it a build. Takes what, 8 seconds? It's like a rodeo. All right, 8.2. That's not a bad time. I saw that Rayon had deadlock detection. Seemed nice. Or was it parking lot? Might have been parking lot. 23. We cut some time off. Okay. I think in here we're gonna have this lock here. There are not many locks in here, are there? Lock on the fleet. But I think this is the actual fleet inside of that each thread is going to be picking up. What do we need? Because there's only going to be like 3 or 4 instances of that. So that's sort of our iter there. I don't know if that's actually all that helpful. If we just did an iter there. For each. Okay. Now all the cores aren't going to be splitting there and then splitting here as well. Say, okay. Have all the cores work on the innermost loop together. We have this fleet. We want to have the ships subdivided amongst the cores. Rayon actually does just what you're saying, which is great. The problem here that I'm having is that this one arguably doesn't need to be locked. This offense is, but the defense does. You know what? Saying that out loud, it makes me think. Let's get that off of there, because the offense is attacking the defense, and Rayon will iterate over the offense, but then each one of those cores has to take turns against the defense. Well, and the fuel. So while Rayon kind of protects you from this object here on 69, the offense, not needing the mutex, it doesn't protect you against the other shared state that you're working against. But yeah, that's a good idea. I'm glad you pointed that out. Because offense doesn't need that lock. Okay. Hold on, I thought it said it needed to be mutable. Gonna borrow behind Thank you. Oh, intermute. All right, there we go. So let's go back to attack. So the outer one, we just intermute over that. Rayon's going to help us with, not that one, because that one's fine. That's each fleet. We're going to go from fleet to fleet to fleet. Then for each of the ships in the fleet, we're going to use Rayon to iterate over. For each with RNG, if it has no energy, it just returns. There's a bug in here, actually. I think that needs to be one of those, which means it's a one of that. Yeah, I like these little puzzles where, you know, I've got more cores. We could do this better. And if I put this on a really big box to compute some sort of computation very quickly, man, it would be great to have a lot of cores and a ton of RAM. Where's the tea? Now like cooling off, I can drink it. Come on, big money, big money, big money. Oh, that's different. And that's all the cores. But it shouldn't be taking that long. Oh, nice. I don't think it should take this long. I'm guessing that Rayon's got some like spin locks or something else in it. Something else. The contention, I'm guessing, is really high. Because this here, that's actually slower than it was before with more cores. Okay, I think I did fix the bug. You managed to integrate your own homegrown library into your project and it didn't crash. Oh, awesome. That's cool. All right, so where's our contention here? Here we have this lock. Is this the only other lock in here? How far can we move that lock in? Move this up. The distribution stuff, that doesn't really matter. But this lock here. What if that will have an impact? Controlling how long the lock lives. Or we can just... I know it's already at the end. I'm just bummed that I'm like using more cores now and it's taking twice as long. Or more than twice as long. You know what? I wonder if it's the cloning of this RNG. Cloning RNGs isn't cheap. Saturating sub. Yeah, all of this is already at the end. These calculations shouldn't take very long at all, and that lock shouldn't live very long. These are very few instructions. Most of the time in the past has been with the random number generator. Flame graph to see the bottleneck. I would have to set that up. I don't think I have that on this machine. Is there a good one for Rust? I think I'd have to basically load it up in a VM because I don't have. I'm running OS 10 here, and I think Linux has better tools for that for Rust. Cargo install FlameGraph. Oh, it should work. Oh, well, thank you. Let's. I would be very interested in seeing this work. Yeah, I guess Twitch is rolling out some new things that you can toss on the channel, and you can have like an intro video. And I was thinking, should make like this absolute like hyperbole of a video, like more Rust, like have like that like a monster truck sort of announcer voice. Um, just like go over the top with like graphics and stuff. I really do think it's going to be the RNG. Gonna be good to kind of instrument that. So how code bullet style intro? Code bullet. I just or personify Rust, make it a monster, a game. Rust always wins. They can have like a sidekick, Clippy. Crab, yes, yes, yes. See, that's doing its thing. I'm gonna actually take a moment. I want to just take a guess at this. Now we have the RNG here from entropy. I'm going to see. We will need a mutex for this as well. RNG clone should technically work. Now, what do people like? How do you feel about arc clone? Right? 'Cause I guess this is the like prescribed way to clone an arc when you want to ensure you're cloning the arc and not calling the clone function on the direct object. You need the arc since nothing will own it. Oh, good question. 'Cause it's really just the mutex getting cloned, isn't it? Well, it needs to be cloned, and the mutex isn't send. All right. I want to just do a quick check because let's see, the previous one, the times for the attack took 69 seconds. It's like higher than it's ever been. So far, the single core version is winning. It did everything in 28 seconds. All right, we'll do this and then we'll do the flame graph stuff. How do you actually use flame graph? We're going to install flame graph. I that up. So yeah, how do you use flame graphs? Okay. Relies on perf on Linux and dtrace otherwise. Oh, does it? It uses dtrace. Oh, nice. Okay, let's go back to the code. Sorry, I was looking at their stuff. Search F3. I want to show threads. It's using all the cores still. Goodness, it's taken a while. I do not think this is a winner. All right, let's use a cargo flame graph bit. 'Cause, yeah, we're already a minute in there. Okay, so cargo. Oh, get rid of that cargo. Okay, here, cargo flame graph. Building without debug info. Okay. Oh, I have to run that as root. System integrity protection is on. My goodness. Oh, and I need to pass config stuff. How do we do that? Guessing I can just do the normal with the dash dash config battle 01. Oh, it didn't like that. Oh, dtrace. Okay, and I think we got this here. Profile release debug true. That's good. Trailing arguments. Okay, config wasn't expected. I give it the usual double hyphen signal that that's what we want. Now I'm getting dtrace stuff. Why is it still saying this? Oh, cargo clean. There we go. Oh, do we have an issue? Uh-oh. Look. Building without debug. Okay. Strange. Same on Ubuntu. All right, I'm gonna let that build up because I'm guessing that it wanted debug info on all of this stuff, not just one thing. And maybe that also didn't recompile it. All right, there we go. And we can give it a binary. This is going to be targets. Dot dot slash targets. I'm in a workspace too, so maybe that'll have an issue. Or Add to that. Battle test. No binary named. Strange. Sure. Can you hack your main just to add the specific parameters just to test it? Sure. Yep, let's do that. Let's change args, but they're not required anymore. There we go. Love note. Here's main, load configs. What does this do? Oh, this just reads a file. Takes a path buff. Okay. I don't remember path buff. Let's go look. New. I can just a string. We can do from a string. All right. I still don't get the that bit though. And yes, maybe we should do this with a smaller battle. I'm gonna overwrite 2.toml. Yes, I know. It's here on all of these counts. I want to reduce that by an order of magnitude. Hit tab, go to the end, hit X. Maybe 2 orders of magnitude. $X. There we go. Much smaller battle, just 1,000,000 against 1,000,000 for sampling. There we go. Oh, look, we got a thing. It's a browser. Can Firefox just handle it? Should be able to drop that on there. Oh, pretty colorful. Wow. That's neat. And it looks like a flame. That's cool. Yeah, what do we have over here? This is helper. What is this? Bunch of rayon stuff. See, I can't see the bottom of this when I'm battle test fold. Oh, if I hover long enough, it'll tell me what it is. Okay, that's cool. I don't, can you guys see the hover? Doesn't look like it. But you can see that little, there's a little pop-up. Okay, so where are we? Do call. Wow, Rand's got a lot going on. Oh, you can click into it. My goodness, that's cool. Search in the top right corner. Oh, nice. I didn't see that. That was so far away. Function names. Okay. Let's see. We wanted attack. Is it like an actual regular expression? Search term. Yeah. Okay. If I just say attack, will it give me something? Doesn't look like it. If we click in here. I mean, I'm seeing a lot of rayon here. I'm not seeing a lot of battle test. All right, here, let's run it with a larger sample. Maybe it'll become more obvious where that is. Well, some of these things, I don't know if these are actually. It's all rayon. Let's change it. Let's give it a little bit more oomph. And back to the counts. Oh, it's just going to show up as rayon? Oh, their closure is running in rayon. Well, that makes sense. We'll just look for the largest closures then. I think it's still going to be helpful. Okay, come back over here. Where did it go? I lost it. Give me a moment. Open dot. Where's Firefox now? I've got a helper, worker, panic thing. So this all begins with battle test because that's binary. I see. Oh, I see. Reset the zoom. This is really cool though. It'd be nice if it had a time on it, so you could click or hover and see how much time it took. Oh, wait, it has samples, and it says it took 60% of the time. We could try to do it without Rayon. I mean, just iterating through these things and spawning cores. It shouldn't be that hard. I'd be surprised if it was really just adding Rayon and using Rayon added that much overhead. It doesn't seem likely. Let's flame in. Hey, we're looking at a flame graph of the application. All right. So 75209, we are trying to multi-thread the application so that it runs on, of course, multiple cores, but it can do some of the work in parallel. So if we go back for that, here's an example. All right, Togglerbit, thank you. I like the flame graph, actually. I think it's very helpful, and thank you for your help. Oh, that's interesting. I wonder why 32 seconds for a system? Huh. I thought that Rayon edition was going to help. I really did. I'm curious, if we don't do this lock here, how much of a speed up do we get? Yeah, you have a question. Oh, it got a bit slow in your ray tracer too. iterators were slower than for loops. Interesting. I've actually found in some cases that the combinators were faster than in for loops. Yeah, that's interesting. I wonder how much we're actually getting out of kind of like the core of the CPU. Things having to sync a lot more. Just a lot more overhead. So is there a logical way to break this up at a higher level? Internal versus external iterators, that's been on various blog posts. Oh, interesting. Hmm. Yeah, let's run that again. There we go. So let's see, battle there took all of 7 seconds. We stash that and build and run it again. Oh, this one's actually using, so right this moment, I'm actually trying to create a comparison between having rayon and not having rayon. And this took really any time at all. 2 seconds. So I just stashed all the rayon code. Oh, we don't have the timings in here. But overall, it took much less time. Yeah. All right, Carter. Hey, take care. Have a good lunch. Yeah, that just takes so much longer with rayon. Surprised. I am very surprised. All right. Well, let's try it without rayon. Oops. That's saved. Oh no, it wasn't. There it is. Okay. Close that. Get rid of rayon there. Ooh. There we go. Creating a list of actions and applying them is interesting. Yes, that is interesting. Hmm. kind of like effects to this thing, kind of pipeline it. Oh, there we go. Oh, that's right. And 4/8 width is gone. Just it shouldn't need that at the moment. I'm just going to remove Rayon and see if what the actual change is in perf. Okay, getting rid of some of those locks. Not declared as immutable. Okay, I think we're close to that checking. Cargo check. Oh, good. Just gonna run it again. I have not tried a flame graph of the non-parallel code. That sounds like a pretty cool idea. There we go. Valid address. Huh. And this is the, this is it. A little bit more simple. Let's see, we run battle, we attack. Interesting that choose weighted takes so much time. I knew it took a lot of time, I just didn't realize it was that much time. Destroy ships, refuel ships. So it looks like the biggest chunk of time is this one function here, choose weighted. All right, let's see if I can get choose weighted out of there. Find OBS again. Go. Okay, choose weighted. This is interesting because I know of another way to do this. Keep transports as a second fleet that fires after the first. Oh, there's more than one fleet. There's like each type of ship is its own fleet. Yeah, there's another way too. Basically, I can just choose a sample from the total number of ships and just know that I have to subtract so many from the first fleet, second fleet, third fleet. Right, so basically order the ships from front to end, starting at like the first fleet and going to the last fleet. And then I just have to subtract from that the volume of the first couple of fleets to know which actual fleet I want to pull it from. Yeah. All right, let's figure this out. So instead of choose weighted, I want to use distribution sample here. This one is actually very fast because I set up the distribution ahead of time, and this is a uniform distribution. It's pretty quick. But I think what I need is just the total number of ships, and then I'll get a number, a random number. I have to figure out which fleet that ship number is in. That should be fine because it'll just be from front end. That should be okay. As we'll reset that on every attack. Okay, yeah, that should work. Oh, you're still in the browser. I'm sorry. I should put up my little warning. Oh, it's white though, so you can't see it. All right, back to the code. All right, code. So we're gonna get the total number of ships. That's going to be targets dot defense. Sure. So it's this exact thing. All right. Map. This is going to be the ship kind. We're going to ignore the fleet. We want to do just a fleet dot length on that, and then a dot sum on that. So now we have the total number of ships. Wait, is that not? Oh, targets dot offense is actually the same size as defense, but without having to lock it. Just different properties of the ship. Is it the offensive side of the ship or the defensive side of the ship? A length here is probably going to be U size. Just keep that in there. Let's get our weight, uniform distribution. Gonna be one of these. The total ships. That's non-inclusive, so it's properly from 0 to total ships -1. I think we can get rid of this now. So, just gonna comment it out, I'm unsure. Okay, now for figuring this out. So to figure out which fleet we're gonna go through, we'll have to get a like target ship index. And given that all the ships have some sort of numeric identifier, which is really their index in the arrays, get the ship index. Oh, this is target. What did we call it? Target attack distribution. So we'll sample that and we'll get some sort of number. And now we figure out, we start subtracting from the different fleets till we figure out which fleet this is in. So we could use a find. No, it's more like a reduce, isn't it? Well, let's just for loop it. For fleet in targets. It's funny, I'm using the offense one because it's not locked. So I don't know why they're... We probably don't need them locked at all anymore, but... Get the fleet size. And if fleet size is greater than the index, so we're going to have to remember which fleet to get this. So we'll have to have a... I'm going to move the target fleet ID out. We'll set that inside of here, hopefully. All right, so if fleet size is greater than fleet size, or rather, let's do it the other way. Let's say if it's less than the fleet size. That is very wrong. This should be target ship index. So this is the case where we need to adjust target ship index and continue on. Yeah, if 1 is equal to 1, yeah. So if this fleet size is too small, we're going to subtract that from the index and continue. Otherwise, target fleet ID is going to be equal to fleet ID. Is it in a loop? It's in a... Yes, it is. The fleets are actually very small, so this should be a loop of maybe... you will only have 4 or 5 fleets. I mean, even if it's like 10 to 20, still not a lot. But technically it is in a loop, and I'm guessing that this is going to be faster than the choose weighted down here. So this is what we're kind of sparring off against, is this choose weighted. So there we have a target fleet ID and our index, target ship index. Should be that. Okay, this, yeah, I saw this coming. This might not get initialized. I don't think that's actually possible. I think it'll always get initialized, but Rust wants to make sure that it's always going to have something. So let's always just start it out with the first one. Targets.offense. first unwrap dot kind. You know what? Let's do it this way. Hold on a sec. Targets is a hash map, isn't it? Armada, offense, hash map. Okay. We'll just iterate through that and get the dot zero then. Let's put that back. There we go. Let's try again. Ooh, slice random is gone. Lovely. I'd like to run it again. There we go. Down to 41 dependencies. That's good. Uh-oh, we panicked. Length is 3,000, but the index is 3,000. Okay. That means we chose a fleet. See, the fleet size. It's less than or equal to the index. Then we skip it. There we go. It's done. Back to the browser. Reload. Yeah. Looking much better. Okay, let's run it on the big data. Actually, how long is that? That's pretty good. Hold on. Main didn't take that change for some reason. There we go. Oh, browser. Okay. Hold on. There we go. Can't write output file. Running the flame graph ends up owning things to changing the ownership of things to root. -r. So this is the one where the battle actually took, best case I ever had was 25 seconds, 26 seconds. Seems like it's taken a while still. Oh, because we have the locks in there still. Oh, that's right, that's right. Got a bunch of locking going on. Yeah, okay, that's better than 60 seconds. I think if we remove the locks, then it's better. Let's go back up to Armada. Basically, the idea then would be to remove these arc mutexes. Spent some time and did some reading on the multivim. A little better at multivim. See if I do slash lock, so DGN on that, hit N. Oh, and yeah, we can get rid of that altogether. Well, it's actually going back to single threaded at the moment. Oh, atomics. Wait, yeah, I want to see how this actually performs with that choose weighted gone. I think it might be fast enough for me. We'll see. Either that or I'll kind of figure out some other way to partition the battle. Maybe have segment the fleets so every other divide the ships by 8 and have them fight each other. Because once the fleets get so huge, it just doesn't make sense. You can actually divide it amongst cores. What if over a certain fleet size we group the ships? Yeah, grouping them. Oh, responding to above. Okay. So I think we want the kind of cache locality, the data in the CPUs. We want it to just be able to burn through it. Almost there. There we go. Let's run it again. I think we can actually run each ship. I don't think we need to get into like the statistical modeling of it. I do think that splitting these amongst cores would work really well. "42 seconds? Not bad, but I seem to have lost some time somewhere." Oh, you know what? I went with the iterators. These elements here. Or where's the flame graph? There we go. We'll do the flame graph again. That wasn't too bad. It was 50 seconds, but it could be better. All right, here we are on the browser. And attack. Oh, get mutable takes 8% of the time. Otherwise, it's this. So I could probably subdivide it a little bit more, figure out where that time's happening. Didn't want to do that. The other element that we could do. So one of the big changes here was that I went from for Rayon, converted these to iterators. So what if we unrolled some of that? Look at the execution time. I see. Okay, now we've converted those just to those elements. So we just went from the combinators to for loops. And shown that again and run that. So before it was at 42 seconds here, 49. Actually, I might have messed it up pausing that. much time? That was 30 seconds. Oh, we got 34 altogether. Which one of these is like the wall clock time? Is it real? Total time elapsed, assumed by the system. The time used to execute utility. Okay. Times. I see. Okay. Well, 34 seconds is quite a bit better than the other. I do think that splitting up the armadas, like every other or whatever it's going to be, would be really nice. I think what I need next is probably some stats. Okay, get it back to the code. Good, you're not in the browser. But it's still not like that 25. What So just converting those, so that saved 10 seconds. Hmm. What do I have? Oh, not that cargo to log file. So close. Tommel. Oh, I see missing opportunities with iterators in some cases. That's too bad. Profiles for the non-packages will be ignored. Oh, look at that. It says that has to go into this. That's why we weren't getting the debug symbols in there. The flame graph stuff. Let's do it one more time with that. I'm hoping that actually adds, like having that at the right place. It's not going to be ignored. my tea. All right, I'm gonna have to go in a minute. Breakfast is served. I get going. Also saw a neat tool which rearranges binaries to give you performance optimizations. So you get CPU cache locality. Oh, I see. It still didn't do it. It's really hoping that would work. Just by having it in the right place at the workspace cargo.toml file. There we go. So OBS, browser, and reload. Yeah, it took most of the time. I think we knew that. But what we don't see here is the get mutable. It's not taking up as much time as before. Oh, Valgrind is awesome. I like Valgrind. Especially for the memory stuff. Double freeze. I used to do a lot of C work. All right, so real time is 32. Pretty good. Yeah, I think the next step is actually just subdividing it and letting this run concurrently across the cores. So if the armadas are large enough, just split them into like 2 pieces, 4 pieces, whatever it's going to be. You should be able to kind of map reduce this down. And I would like to be able to run this inside of maybe instruments. All right, I'll figure that out, how to get instruments on screen and how to run it inside of instruments, maybe for tomorrow. All right, y'all. All grind tool. All grind, yes. Cache grind. Hey, look, Gamozo, Gamozo is still streaming. Let's raid him today. Well, I mean, either him or let's raid him. All right, y'all. I gotta go have breakfast and coffee. Thank you all, and we'll try making this concurrent kind of across the cores by subdividing the armadas, basically splitting them into pieces that are large enough so that we're not losing out on any sort of interesting gameplay. Yeah, it'll be good. Try this. All right, talk a bit. 75209. I'm Good hanging out. See y'all. Bye.